Okay, can you see now my screen?
Yes, doctor.
Okay, I started the recording as well. Let me just go ahead and do some revision on chapter 4 because we have covered this like a few months ago. Just a refreshment for your knowledge. So here we covered the definition for electromagnetic signals. So they are electromagnet energy that travels in waves and that radiates outward from its source. Okay. We have a transmitter, okay, and we have a receiver. And the signal is transmitted or carried over transmission media. This media could be wire, wireless, space, okay. And this electromagnetic signal is a function of time or frequency. And you need to know the equation for frequency. Frequency is equal to 1 over time. Okay. Frequency is equal to 1 over time. So if my signal, let's say here, takes 1 second to form one full cycle, so the period, the time taken to complete one cycle is called period. So signal is frequency is equal to 1 over period. So it's 1 over 1, it's equal to 1. Okay. And we have difference between analog signal and this digital signal. Analog signal, it has discrete values changing over time. Digital signal, as you can see here, okay. The signal intensity maintains a constant level for some period of time and then changes to another constant level. And here, as you can see, it goes up, stay up for certain time, then go down, and then stay at low level for certain time, then go to that high level, as you can see. So we have either like low or high, but analog is changing over time, continuously changing, as you can see here. Now, the analog signal might represent speech, music, or video. If they ask you, for example, for analog signal, so it is speech, music, or video. Digital signal might represent binary 1 and 0. You need to know also these definitions for periodic signals, such as peak. Peak is the maximum height of the wave above or below a given reference point. So if we come back here, the peak is here, this point. Can you see my screen here? This is the peak, or this is the peak. Okay. And the peak represents the strength of the signal. Allahu Akbar, Allahu Akbar. Ashhadu an la ilaha illallah. And it's measured in volts. So for peak, amplitude is in volts. Then we have frequency. Frequency is number of times the signals makes a complete cycle, as I just mentioned. And the unit for frequency is hertz, okay? Hertz means cycle per second. Period is the time interval for one cycle, how long it takes or how much time it takes to complete one cycle. Then we have phase. Yes.
سوري دكتور قاطعتك. دكتور بس
Sorry?
انا كنت سوري دكتور قاطعتك دكتور.
Sorry?
اقول سوري دكتور قاطعتك. اسمح لي دكتور.
لا تفضل تفضل.
دكتور بس انا كنت بعرف شو الفرق بين بريود والفريكونسي، يعني انا اعرف كلهم ان تايم يعني فور وان سايكل، بس يعني شو الفرق بينهم بالضبط يعني؟
Between what and what?
فريكونسي وبريود.
Okay. Frequency meaning how many cycles are there per second.
في
How many
الثانية يعني.
cycles are completed per second.
تمام
How
دكتور
many
تمام.
cycles per second is frequency.
يس دكتور.
In Arabic it's called تردد.
هي عرفنا بالعربي، بس كنت بعرف الفرق بين
Hey,
هذا
hertz
والبريود يعني
يعني
هي
how much time, how many times it complete one cycle in 1 second. Okay.
هي تمام دكتور، يعطيك العافية.
Period is how long, how much time is needed to complete one cycle. So if we come here to complete one cycle, I need this time. This is the period.
فريكونسي.
لا, this is the period.
period.
The
اوكي.
time needed for 1 second, for one cycle. يعني it starts from here, when it comes back to its original state, this is one cycle. So the time needed for one cycle is called period. Okay?
اوكي دكتور.
If it makes one cycle in 1 second, then the frequency is 1 over period. 1 over 1 is 1 hertz. Type if it is very fast signal and it makes 2 cycles per second. 2 cycles per second. So what is my frequency? As I mentioned, my frequency is the number of cycles per second. So if it's making 2 complete cycles per 1 second, then the frequency is 2. And the period is 1 over frequency, 1 over 2, yani half. I will show you one example here. It's very clear here. Look at these examples, everyone. Let's see the first one. Let me try to make it bigger. Look here. What's my amplitude? 1. Okay, 1 volt. My amplitude A is 1. The maximum.
The height and for
1.
this. Yes.
Correct?
Yes دكتور.
Okay. طيب, what is the period? From 0 till 1, because this is a complete signal, a complete cycle. 0 to 1 second. I have 1. So my frequency is 1 over period, which is 1 over 1 equal to 1. خلاص? Is it clear now?
Yes. Yes دكتور.
Alhamdulillah.
Thank you دكتور.
Very good. So let's come here. I have another example here. I have the peak value. Peak is the same. It is 1. But this signal, we can say generally that it is very fast because it is making 2 complete cycles in 1 second. 2 complete cycles in 1 second.
Mean the
Okay.
frequency is 2 here.
Frequency is 2. And what is the period?
Period.
Period is 1 over frequency, which is
0.5.
0.5.
Yes.
Because 0.5, I completed only 1 cycle. Very good. Okay.
Okay.
Let's see this one also. Period. Here the amplitude is lower. It is 0.5 volt. 0.5 volt, the amplitude. What about the frequency?
Is 1?
1. Because the
Yes.
time needed to complete 1 cycle is 1 second. So the frequency is 1 also. Yani you can't, yani, to imagine a frequency, it's like the speed. How many kilometers per second? So here, the frequency, yani the speed of the signal, how many cycles per second? Okay. I think now, I hope it's clear. One more point. Here we have also more definitions. Frequency, some definitions about the signal and can you hear me or?
Yes, yes, doctor.
Yes, yes, doctor.
Yeah. A spectrum is the range of frequency that a signal contains. So the whole range is called spectrum. The whole range, the weak and strong signals is called spectrum. However, in the middle or the narrow band of the frequency where most of the signal energy is found is called effective bandwidth. The absolute bandwidth is the width of the spectrum, but the strongest part is called effective bandwidth. And the effective bandwidth is the one we need, the one we use for transmitting our data. And the greater the bandwidth, the higher the information carrying capacity of the signal, of course. Okay, so you have to know these definitions. Any questions?
No, doctor.
No, doctor.
Just hold on, please. I think I received email. Okay. Just hold on 1 second, please. I have a request from a student from different campus also for tutoring, trying to help. Okay. Hi. Okay. Let's see now, what do we have? Okay. Now let's talk about the analog signal and the human voice frequency. Where a human talking can be represented as an analog signal, okay? Because while you are talking, your voice frequency, your voice amplitude is changing. It's not like digital, it's not like constant, okay? As you can see here, the variation in amplitude and frequency convey the gradation of loudness while you are talking in speech or in music. Similar signals are used to transmit television picture, but at much higher frequency, of course. You will need higher frequency for that. Okay. Now let's talk about the exact values. For voice, a human voice range from 300 to 3.4 kilohertz. Okay. So for the telephone to be able to cover this frequency, we give it a channel of 4K or 4000. So you have in the telephone system, when they design the channels, the telecom engineers, they calculate that for a human voice channel, it should be from 0 to 4K. Inside that, you will have the human voice bandwidth from 300 hertz to 3400 hertz. Why it's not exactly from 300 to 3000 for? Because we need something called guard band. Guard band at each end of the frequency range. It is to prevent interference from other adjacent voice channels. Okay. So this is the function or the benefit of having a guard band. Now for video or television needs a higher frequency, similar to the telephone handset, but it will be on higher frequency. You will need around 4 megahertz, okay, to transmit an analog video. All right, but because also we need guard bands, so a channel is at 6, each channel is 6 megahertz. Why? Because we need for color and for the guard band, so 6 megahertz is enough for each video channel. Okay. So I hope you remember these numbers. Now this is a digital signal. We can also measure the bandwidth. We can measure the frequency. Here the peak value for the signal is 5 volt. It is 0. When it is at 0 level, binary, it is 5 volt. When it is at 1, it is -5. And each interval time is 0.02 millisecond. Now, these are the different type of transmission impairments. The first one is noise. And this is the enemy of telecom, the noise, because it can cause bit errors. Noise is a collective term for various transmission impairments. Because also electromagnetic or electrical energy, they degrades, the noise degrades the energy, the signal quality, and it will introduce random modification to the signal. Yani I am sending a signal with the noise, maybe I will get different. When the receiver receives the signal, is receiving like a distorted, okay, signal. And this distortion can be from very small, like they call it HISS, H-I-S-S, or to complete signal loss. Maybe the whole signal is lost because of the noise. Now, we have divided these impairments into according to the media. So for the guided media or cables, such as twisted pair, coaxial cable, and optic, we have the attenuation. Attenuation is that the signal, when it is traveling longer distance, it is getting weak. We call this attenuation. We have also delayed distortion, and we have noise. So this is the definition for each one. So for attenuation, we have to make sure that the receiver is receiving a good, strong enough signal so that it can be understood. Okay. طيب. To overcome attenuation, what do we use? Please pay attention. For digital signal, we use repeater. Repeater is very good for digital because it will regenerate the signal. Yani the signal will be regenerated as per the original signal. Here, see here. So the noise was removed. You cannot upload, I think, doctor. Yesterday, we were not able to upload. بس Okay, now this is the repeater. For analog, we use something called amplifier. However, the problem with amplifier is it will amplify everything. Okay, the normal amplifier will amplify the whole signal. Okay, so for digital, we are using repeater, which is very powerful. Then you can send the signal also further distance. We have also the delay distortion. Here, various components of a signal arrives at the receiver at different times and occurs in transmission cables. It does not occur when signals are transmitted through the air, through the means of antenna. What is the reason for this delay distortion? The velocity of propagation of a signal through a cable is different for different frequencies. And this is physics. Okay. But it is very important or critical for digital data. Noise. Noise is the major limiting factor in communication system performance. It can be divided into 4 categories. We have thermal, because of the heat. Okay. We have, hold on, please. You can still see my screen, right?
Yes,
Correct?
Doctor. Yes.
Yes, Doctor.
Yeah, good. Thank you. Sorry. Trying to arrange this. Okay. All right. So now, just hold on. I think the sharing has stopped. أهلا دكتور، السلام عليكم. هلا دكتور، صباح الخير. هلا. Okay, I'll start the share again. All right, can you see the share? PowerPoint?
Yes, doctor.
Okay. So this is, we talked about the noise. Noise can be thermal because of the heat. It can be intermodulation, is when a signal of different frequencies share the same transmission medium. It can be crosstalk or impulse noise. Impulse noise, yani something that's coming like an impulse spike. You know, like when there is lightning, so you will find that you might get some disconnection or some impulse. We call this an impulse. Suddenly the signal will go high. And by the way, this is not good for electronic equipments that are sensitive. Some of them are very sensitive to these impulses. They could damage the circuitry. Okay. Now, if we want to see how it affects your signal, as you can see here, let's say this is my original signal. This is the noise. If you add them together, look how you get this distortion of the original signal. The original signal become like this. You see, it's very distorted. So when the receiver receives the signals and then try to interpret it, convert it back to data, zeros and ones, you can get some errors in some bits. Okay. Now, what about for wireless media or space? We have free space loss. Same thing, like everything in this universe. Signals disperse with distance. It become weaker. Automatic absorption by the water vapor and oxygen. Multipath. Multipath, yani, let's say you are inside a big room or a big hall. Then you're transmitting your signal, because it's wireless, it's taking different paths to arrive to the destination. It is not contained in one cable. We have also refraction when the signal is traveling from different media, like it's traveling from, let's say, from the air to water, or through the wall. We have also thermal noise. Okay, it's also affecting wireless. It is also affecting in wireless communication. Now let's talk about the channel capacity. The channel capacity is actually the rate at which data can be transmitted over a given communication path or channel under given conditions. This is controlled by 4 values: the data rate, the bandwidth, the noise, and the error rate. So these are the values that contribute to the channel capacity. Now, this is very general slide, but actually, if you are going more into telecommunication and need to study more, you will learn more about these concepts. Okay. So in summary, signals for conveying information, we use electromagnetic signals, analog signals, and digital signals. We have transmission impairments affecting channel capacity, and they can affect guided media or unguided media, and they can affect also the channel capacity. So I think that's it for this. I will stop now and I will take your question. Let me just hold on, please.